These are the different types of interrupt. Before seeing different types of interrupts, the address location of different interrupts is very, very important. As I said, in software interrupts in 8086, from 0 to 255, 0 to 255. So there will be 256 interrupt. These 256 interrupts is classified into three. That is dedicated interrupt 0 to 4. 0 to 4. It is called as dedicated interrupts. You can see here 0, 1, 2, 3 and 4. All these four are dedicated interrupts. And from 5 to 31. 5 to 31 it is called as reserved interrupts for higher processors. It is for reserved interrupts. And from 32 to 255. 32 to 255. Totally 224. That is user defined interrupts or available interrupts, right? So dedicated interrupts in the sense it is dedicated for certain operation. I'll explain it little later, right? And reserved interrupt, it is for reserved for some high processor. And available interrupt is nothing but it is for user defined. Whenever a programmer want to create an interrupt program, they can use this available interrupts. They can create a program for the corresponding location, right? And this different types of interrupts, right? Apart from this different types of interrupts, you have to understand what is interrupt vector table, right? So in interrupt vector table, I have said what is dedicated interrupt, what is reserved interrupt, what is available interrupt. Each and every interrupt will have its own dedicated address location, and that is why it is called as vectored interrupts. All this are called as vectored interrupts, right? So what is the address location? Here, each interrupt, listen very carefully, each interrupt in 8086, right? It will occupy 4-byte address. It will occupy 4-byte address. 4-byte address. Sir, why it is 4-byte address? I have already said each address, right? Each physical address, it will be having, it will have CS and IP, right? The upper part will be saved in CS and lower part will be saved in IP, right? So CS will take 2 byte and IP will take 2 byte. That is why each vector has 4-byte address, right? So if you say 4-byte address, now you can see here it is 256 totally. So if it is 256 into 4, around 1 KB. So the interrupt alone will take 1 KB of memory of 8086, right? Now you understand why we have CS and IP, and CS takes 2 bytes and IP has 2 bytes. That is why we have 4-byte address for each and every interrupt, right? And one important thing is, since it has 4-byte address, right, the location of each interrupt, right, the type interrupt, that is, say for example, if it is type 2, you can calculate the address of type 2 interrupt by yourself. That is, we know that each interrupt has 4 bytes, 4-byte address, right? So if it is by type 2, 2 into 4, the address location will be 8, right? So you can see here for type 2, the address location is 8, right? Similarly, for type 1, it will be 4, right? So it is 4. So like each and every type, right, it can be 32, whatever number. If it is, say for example, if you want to calculate the address location of type 32 interrupt, then 32 into 4, that is the address location, right? So calculating the address location is very easy, right? Which means each and every interrupt has 4 bytes. As I said, the 0 interrupt, you can see it starts from 00, and the type 1 interrupt, it starts at 004H, and the type 2 8H, 0CH, all are represented in hexadecimal format, right? So it will be split into 4 bytes, right? Now you understand what is interrupt vector table, how are this different types of interrupts that's been splitted, right? The address location, and you can see the interrupt vector table again, like the dedicated interrupts 0 to 5, and as I said, the reserved interrupt, right, that is 27, and available interrupt to 24. And as I said, if you take type 0, it starts from 00, right, and type 1 starts at 04, and type 2 8, like that it goes on, right? And for each and every type, you have 2 byte for CS and 2 byte for IP, right? And even in that 2 byte, we can able to split it as higher byte and lower byte. So you can see here, I said 2 bytes for CS and 2 bytes for IP, right? In that 2 bytes, you can see here 00 is considered as lower byte, 01 is considered as higher byte. Similarly here, 02 is considered as lower byte and 03 is considered as higher byte, right? Like that it goes on, right? So even in that 4 bytes, we can split it as 2 for CS and 2 for IP, and even in that 2 byte, we can consider it as higher byte and lower byte for CS and as well as IP, right? So this is how the interrupt vector table is there, right? And that is why whenever there is an interrupt, a particular interrupt, the microprocessor will directly go to that address location because it has well defined address location. It is vectored interrupt. So you don't need to waste time to find out the address location, right? For any type, it knows the address location. It goes to that address location, serve that interrupt, and come back to the main program, right? And you can also calculate the address of each and every interrupt. As I said, you can see here, if the question is given like this, INT02H, find out the ISR address for 02H. That is nothing but interrupt 02. That is type 2 interrupt. So type 2 interrupt in the sense, as I said, type 2 into 4. So it is 008, right? So the address location is 0008H, right? So as I said, you can see here 2 bytes for CS and 2 bytes for IP, right? So for any particular interrupt number, you can able to find out the address location, right? And coming to different types of interrupts, as I said, we have 3 different types, right? What are the 3 different types? That is dedicated interrupts, and then we have reserved interrupts, and then we have user defined interrupts. So if it is 002, 04, it is dedicated interrupts for any fixed operation. We will see all those 4 interrupts separately, right? So those are called as dedicated interrupts. And 5 to 31, it is not used interrupts by 8086, but it is used by higher processor. As I said, the higher processor 80286, 80386, like that, right? And the last one is user defined interrupt, where you can see it is from 32 to 255, where a programmer can define their interrupt program. Say for example, if you're going to write an interrupt program, a programmer going to write an interrupt program, and if he's going to if you're going to save that in the say for example, if it is interrupt 34, then it's nothing but this particular program will be saved in the location 34 into 4. In that location, that particular program will be saved. So whenever the processor comes across that particular address location, it will serve that particular program. That is called as user defined interrupt, right? Now we'll see what is this 4 dedicated interrupts. So 4 dedicated interrupts, the first one is divide by 0 error interrupt. What is divide by 0 error interrupt? This is very common interrupt. That is, whenever we give any normal instruction, the processor will perform that particular instruction, right? It will provide the output and the result will be saved in accumulator. All those things we know that, right? So whenever there is a normal execution, there will not be any problem. But whenever there is a special condition, right? Whenever there is a problem, or if does not satisfy the condition, right? So then this interrupt will take place, type 0 interrupt. For example, if division, right? Normally, you know, the divisor, it will divide, right? And it will provide the quotient and remainder. Say for example, if the divisor is going to be 0, then it will provide the quotient as infinite, right? So if it is infinite, you cannot be able to save that particular value in microprocessor. So in that case, type 0 interrupt will happen, right? So whenever there is a special case or whenever there is a problem like this, type 0 interrupt will happen, right? And type 1 is single step or trap interrupt. That is, whenever the trap flag is 1, TF flag is 1, then this type of interrupt will happen. When this type of interrupt happens, then microprocessor will execute step-by-step instruction. That is, it will execute in single step mode. I have already explained while explaining the architecture, what is single step mode, right? So whenever the processor come across this condition, it will enter into the single step mode. That is called as type 1 interrupt. And type 2 interrupt, non-maskable interrupt. This is high priority interrupt in 8086. It is non-maskable. Non-maskable in the sense we will not be able to control it, right? So that is type 2 interrupt, and as I said, it is a non-maskable interrupt, right? We will see that it is also an hardware interrupt in 8086. We will see that separately, right? And next one is type 3 interrupt. This is 1 byte instruction interrupt. That is, we use this interrupt whenever there is need of breakpoints. Say for example, if you're going to execute a program, a very large program, right? Then we will not be able to check some logical issues periodically, right? So we have to wait the complete execution, and then we have to check what are the errors, right? And if there is error, then we have to correct the complete program and we have to redo it, right? But if you use this interrupt, that is, it will create breakpoints between the programs, so that if we create breakpoints, then and there we can check there is any logical errors or logical issues, and we can correct it, right? So that is called as type 3 interrupt. And what is type 4 interrupt? This is overflow interrupt. Whenever the overflow flag is enabled, then this interrupt will happen, type 4 interrupt. So these 5 interrupts, type 0, type 1, type 2, type 3, type 4 is dedicated interrupts, right? Whenever these conditions is going to happen, then this interrupt will get created, right? And whenever this interrupt is created, what will happen? The microprocessor will go to this address location, and it will follow all the steps which I said, and it will serve that particular interrupt, correct? So today what we have seen is, we have seen the interrupt vector table and interrupt operation of 8086, right? I believe this video will be very useful for you. Thank you, my dear students.